So how many of you, by show of your hands, show me use AWS today? Whether it is development, production. Cool. And we have about 40 minutes today. Security is a large topic, and I will try to cover the high level, and we'll try to go deeper into a couple of areas because Kelvin wanted to look at something deeper rather than just broad. What's your perception of security in AWS or cloud in general? What do you hear? And does anybody want to say something about it? Oh.
I always want to know where it starts and where it ends. Like, what do you cover and what do I cover? That's always my question.
Yeah. Okay. Well, this seems like it's off now again. Okay. Well, I think we'll cover that security in the cloud and security of the cloud. But like if you, with AWS, everything starts with a customer. So when you look at some of the workload that runs on AWS, like if you're familiar with FINRA today, which manages all of the market transactions that are happening in the stock market today, right? So it's trying to figure out if there is any insider trading happening. It collects 35 billion events every single day, petabytes of data. On a good or a bad day in the market, it can go up to 75 billion records, right? US government uses AWS. There are other customers, DNA Nexus, Slack. These are just some examples of customers that use AWS, and they do it because security is a differentiator for them. So security is the job zero at AWS. When we start out, if we didn't have the security, we would not have this business. Some of the reasons customers use AWS is it has a higher standard. One of our largest ecosystems of partners that provide tools and services that you're used to today in on-premises, those are also available on AWS. So you can use those same exact tools in addition to what we provide. We are also going through independent audits all the time, third-party audits. The benefit there is that the work is divided. So today, if you are running a workload in AWS or on-premises, you are responsible for managing the security of the physical infrastructure, the network, the servers, operating system. All of that is your responsibility. With AWS, we take care of that global infrastructure, and it is being audited, so some of those controls are available through the third-party certificates that we provide, and they are available through AWS Console. We have a service called AWS Artifact that you can use to download some of these reports. So when it comes to AWS and security in the cloud, we divide this responsibility in two ways. We like to call it security off the cloud is AWS's responsibility, but security in the cloud is your responsibility. What does that mean? That means that the physical infrastructure, the regions, the availability zones, the edge locations, the network, all of that is responsibility of AWS. We go through strict audits, independent audits, and they are available to you also to review. All of the compute, storage, database infrastructure is secured by us, and you have control anything about hypervisor and up. So hypervisor is controlled through AWS, but then if you're running a server, a virtual machine, if you're running a database, then if you're creating a virtual network, the ability to configure is your responsibility, and do it right is your responsibility. But we do provide a lot of tools and services. So the things that are in yellow, like configuration of operating system, whether they are being patched, they have the right kind of patch level, whether you have your data encrypted, we have a number of services and tools that helps you achieve that compliance. If you're looking for certain compliance level, if you're running like a PCI DSS compliance, then what this model allows you to do is that you can inherit some of the controls like physical infrastructure control that PCI DSS requires through our certifications. But you do have responsibility of configuring your network correctly using the best practices. And we have certain white papers and best practices guidance on how to do that. So again, looking at it different way here just shows what AWS's responsibility is, what customers' responsibility is, network configurations, security groups, firewall, operating system, keeping up to date patching, building your application in a secure fashion, encrypting your data at rest. You always control where your data lives with AWS, so we do not move the data at all. You pick a region, you pick a availability zone where you store your data. So the certification that we provide that covers the left side of the box, and then you add the additional control, and you can achieve the certification that is on the right. So together, you can achieve this compliance. So when it comes to security, there are large number of tools, and these are not all of them. We'd like to divide into 4 different categories here. On the top left, you have the networking and security, which is where you have all the VPC, which is our virtual private cloud, where you bring your CIDR block and you create your virtual private cloud. You can define manage VPN connection on AWS side. You can define a lot of security group, firewall rules. That's all covered under network security. Identity and access management. Okay. Identity and access management is other area. So this is the area where you control who has access to what in cloud. So authentication and authorization within AWS is yours, available through IAM. We also have managed directory service, so you can do Active Directory in AWS. You can also host this directory independently or have it trust to your existing Active Directory. So you can do a lot of federation type of work also. Encryption is another big area, so we have a number of services, and we'll go through that in detail when we get to encryption, but there are services that allow you to encrypt the data very easily. When it comes to encryption, key management is a big responsibility, and when you're doing it at a scale, it's really hard to do that work. And some of these services allows you to take care of that heavy lifting for you, undifferentiated heavy lifting, and makes it easy for you to encrypt the data at rest. And we have a number of services that allow you to do configuration management, logging, monitoring. If there are any changes that are happening in your environment, you like to be notified. So we have services in AWS config. You would like to create your databases or your network in certain way, standardized way. So we have services in CloudFormation that kind of works as a cookie cutter where you can similarly create the networks over and over again. You also have services like Service Catalog, which allows you to create products and portfolios that you can share within AWS account so that there is a compliance in certain way how you build your products and services. So what this means is we have number of services and tools available. In fact, there are too many of them, but every tool has a specific purpose of it. So if you are looking for something like encryption, we have 3 different services like Cloud HSM, KMS out there. If you're looking to secure your workload through firewall, we have security groups, network ACL, routing, all of those are available under our AWS VPC. It's out there. The idea is that take care of all the undifferentiated heavy lifting for you so you can focus on what differentiates your business and your application more, and do it really fast and quick. You always have full ownership of your data. As an AWS employee, we don't have access to regions, availability zones, or any of those facilities. We don't even know where they are. It's only need-based, so company allows access to only employees that need that access to those facility for their job, for their role. So let's talk about a little bit on identity and access management. So identity and access management is a service that allows you to do authentication and authorization in AWS. So AWS is a group of services, whether it is a VPC, whether you are creating an Elastic Compute Cloud EC2 instance, whether you're creating a database, every service that you are interacting in the console, you have to have access to that service and that action. And it's a very granular access control that it provides. At the core of IAM, there is something called a concept of policy. A policy is a JSON document, as you see on the right-hand side. There's a syntax, specified syntax. It's a very simple syntax. If you look at it, it consists of a statement. And in statement, there are 4 key elements, and we call it a PARC model. A PARC model stands for principle, action, resource, and conditions. So when you look at the principle, there are different types of principles. And each JSON policy can have one or more statements, and these policies are attached to a principal, a user. It grants you the permissions that user may need, right? So, for example, a principal example could be an AWS account, could be a principal. And in this case, on the first case, we are saying that allow everybody access. So this is the way to provide a principal in a policy. The second example shows a specific AWS account has access. You can also give access to a specific user within an account. So you can have multiple users within an AWS account. Each user can be granted permissions. You can also federate the user. So if you are using any federations like ADFS Federation, Microsoft AD, or any popular web federations like Google or Facebook, you could use that also as a principal. You can also give access to a role. A role is a different type of entity. Think of role as a non-human ID, where you have an application that needs access to certain resources in AWS. So when you're running like an EC2 application and you want to write an image into a S3 bucket, so for that, you don't have the user ID and password, so you need a temporary permissions for that EC2 instance to write into the bucket, and you can assign a role to EC2 instance, and the role would be the principal in that case. You could also have a specific AWS service granted the permissions. So by default, not all AWS services have permissions. Think of CloudTrail, which is our audit service, where you can see what actions and what services are being used by who, when, where. That service may need permissions to write into your S3 bucket. Well, you have to grant that permission. So in that case, CloudTrail will become your principal. So there are principals, and each principal has a specific format, what we call it Amazon resource name, which is what is the pointer showing there. And you can replace the account number, which is unique to your account. The second example is the actions. So when it comes to actions, there are different types of actions. You can wildcard the actions. You can say EC2 start instance. You only grant that permissions to somebody, or you can say stop instance. So you can control the permissions. There is a NotAction, which is basically saying that everything in this policy, give access to everything other than IAM. So what we are saying is that with this policy, the user who is granted this policy will have access to everything other than anything with IAM. So he cannot create the user, he cannot create access key pair and things like that. So you can design these policies as you need. We also provide many managed policies, so you could use the existing policies that we provide also, but you can customize it to your requirement. On the right-hand side, you have a policy that says, the first statement says, allow access to everything in AWS in that account. But the second statement says, deny IAM permissions. So you would think that these two are equivalent. Can anybody spot the difference, why they are not equivalent? No? Well, the IAM policies are evaluated in a slightly different way. Here we are saying that it's not anything other than IAM is allowed. The difference is that on the left side, you can grant additional permissions later on through another policy. So a user can have one or more policy. And you can say, now I'm allowing IAM-specific permissions, and the left side policy will not block the access, whereas right-hand side policy would actually block the permissions, and the user will never have the access, because once you deny permissions, then they would not have access to that. So the other area is the resource. The resource could be an S3 bucket. It could be a specific object within a bucket. It could be a specific EC2 instance. It could be a relational database. It could be a SQS queue. Pretty much you can think of the things that run within AWS in form of resource. And you can control access at a specific resource level also. The fourth element is the conditions. So conditions are kind of adds more layer. So you could say that for this principle, I'm giving this actions on these resources. Like I'm giving a user access to start an instance, a specific instance. That's all I'm giving. But then I can also control that if that API request comes from a specific network. Suppose you want to control your access from your company's network. If you are on VPN of the company, or if you are on a specific IP range, then you can control that access through this range also. So IAM conditions are ended. So here we have 3 conditions. We are saying that allow this access only if it is within this time frame, and only if it is coming, the request is coming from a specific IP range also. So you can get really, really granular with IAM policy. So here's an example of a complete policy, which is basically saying that whoever is granted this policy has access to list a specific S3 bucket called my bucket, but also only a specific part of the bucket. So if I'm a user Viral, I will only be able to list home/Viral, because my username will be replaced at a runtime, so I get a partial access to my bucket. And then I will have other S3 permissions like get object, put object, those kind of permissions to a specific folder within the S3 bucket. This is another example here where we are saying that a principal who is assigned this policy would have all these EC2 actions, start, stop, run, reboot, terminate instances, if that user is requesting those actions in those 2 regions. So US East 1 is Northern Virginia, and Oregon is US West 2. And if the instance type is T1, T2, and M3. So you can control who can do what very granularly. So a little bit about, I mentioned that a user can be granted 1 or more policies. Each policy can have 1 or more statement. It can have conditions. So how does the policies evaluate? So this is the logic of how the policies evaluate. So we gather all the policies that apply to a user. The first thing by default, whenever the user is requesting, we start at a default deny. So we started at the user is denied access to everything. Then we evaluate all the policy. If there is an explicit deny of specific things that has been called out, then that action, we stop the evaluation and say that user is not allowed. So when you explicitly deny something, no matter how many times you do allow after that, it doesn't work. It just stops right there. Then we look at if there is no deny, then if there is an explicit allow. If there is an allow, then we allow that action. And then that's where it ends. But if there is no allow, by default, it stays deny. So by default, nobody has access to anything in your account until you create the policies and grant them permissions. And so that's how the policy flow works. This also gets somewhat, there's other aspects of the credential management and access control, that some of the resources, like for example, S3, SQS, SNS, these also support resource-based policy. These policies are defined on a specific bucket, and you can think of that as a policy that protects only that resource. And so IAM policies are attached to the users, but resource policies are attached to the resources. So when it comes to accessing a specific resource that has a resource policy and IAM policy, the intersection of those two apply. So you may have the permission through IAM, but a specific bucket may have denied the permission. So in that case, you may not have the access to the bucket. So that's another thing to keep in mind there. So some of the best practices for IAM, so when you create an AWS account, you can create access key. We recommend don't create access keys for the root account. In fact, if you have, lock them up. Create individual IAM users. Do not share the credentials. Everybody should have their own IAM users, and even better, federate them with existing identity. You can group them, so you can have all the DBAs in one group, all system admins in one group, specific group of developers in one group. So that way you can have one policy that applies to the entire group, and you can put the users in that group. You can have a user in multiple groups also if you need. Configure the password policy, so you can make a complex password policy. Use multi-factor authentications on AWS root account, or like if you have a privileged admin account, IAM account, you can enable multi-factor authentication. And if you don't have hardware token, use something that is like a phone-based soft token, like Google Authenticator or Authy or something like that, that will protect your account. Use roles. So this is another important area. So when you start building applications, these applications are run on EC2 or maybe running in Lambda, and it needs access to a queue, or if it needs access to a specific objects or a bucket, you want to create the roles with the least privileges. So you do not want to add all the privileges, or you don't want to create a user with the admin policy and then use those access keys in the EC2 instance and think about closing it down later, rather than start with the least privileges, add more as you need, and that way you are building the security from ground up when you're building the application. Rotate the credentials regularly, so you can force the credential rotations. For example, you can expire the password at certain interval. Remove unnecessary credentials also. So if it's not being used, remove them. Use conditions. Conditions are, it's initially a little hard to understand, but once you get handle of it, the easiest one would be to control from where the AWS account can be accessed, like from a approved network. Yes, there's a question. In the, which one? Okay. Yeah. I don't have the exact information at this time, but I have the contact of Calvin, so I'll take your email after this event and then try to get you the information that you need. I'm not aware of the change in that at this time, but I don't know if there is anything on the roadmap at this moment. Okay, and then keep an audit log. So CloudTrail we'll talk about that a little bit, but that's important. The second aspect, we talked about identity and access management, and then let's talk about a little bit on network. AWS allows you to create a virtual private cloud. What does this mean? This means that you can bring an RFC 19 IP range, any 10.0 network or 192.168 type RFC 1918 range, and think of these IP range as extension to your existing network. So you can take a specific CIDR block that you're not using on-prem, Make sure that you don't overlap that, even though you are not connecting the two networks today, but eventually the networks would require some connection, and then you may have trouble routing the traffic. So basically use an RFC 1918 IP range that is unused in your current network, and you can build the network across multiple availability zones. You can define the security groups. So security groups are, think of them as a stateful firewalls. You can define port and protocol for any traffic coming into EC2 or going out to EC2, or relational database or any EMR clusters or things like that. You can define the security group around those. You can also define network ACL. These are network access control layers. These are around your subnets. So when you think of VPC, it is divided into multiple subnets, and these subnets, you can think of some subnets, maybe public subnets where you are running your public internet-facing load balancer, but all your servers are running in the private subnet where they don't have direct access from internet. So you can put them in the private subnet. Anytime the traffic goes in and out of subnet, it has to go through the network ACL. So you get to define the network ACL controls, like what port, what protocol, from where the traffic is coming in and going out. So you can do that. Routing table is another way to route the traffic. So if the packet is going from VPC down to your network, you can define that in the route table. If the packet is going out from your VPC to internet, you define that route. If there is a network address translation, like a NAT device or internet gateway, those all controls are available. And there are best practices, and there are many templates out there to start from, so you don't have to build everything. There are certain architecture, like for example, we have some best practices around PCI DSS compliant. How do you build your network? So you can start from there. There are white papers and already built template out there that you can use, and then modify it from there. Encryption is another area. So we have encryption on wire and encryption at rest. So when you look at the encryption in transit, we have HTTPS. All of our APIs have SIGV4, and they are TLS 1.2 encrypted. We also provide VPN, managed VPN on AWS sites that can terminate on your side on premises, or you can do VPN across the VPCs also. And if you look at some of the services that we provide, this is a Amazon Certificate Manager, AWS Certificate Manager, which basically provides a trusted TLS certificate. The service is at no cost. Basically, you can create a certificate, a public certificate, and install it on your load balancers, or CloudFront distribution, or like if you're building an API through API Gateway, you can use that at no cost, and it provides the termination. You can terminate those, like for example, you can get the TLS traffic to your load balancer, terminate it, or you can take that traffic all the way to EC2 instance, depending on how you configure it. This ACM certificate, now we just came out with a private CA also, so there is we can provide you as a certificate authority, which you can run within a VPC also. So there is a public aspect of it, and then there is a private CA where you can create the certificate in a private VPC and then use it within your network also. And there is a charge for that. But the way it works is you provide your domain, and then there's an email validation. So we send you to the admin of that domain the thing to request to validate that. And once it is validated, you can start using it, attach it to your load balancer.
Is that root separate from the trusted break for AWS? So there's an AWS trusted break that's in browsers and stuff. Is this part of that, or is this a separate?
So this is on the server side. So what you say on the browser side is already there. So client-side certificate, this is not client-side certificate. This creates a certificate for, say you're building a website under your domain, and you'd like a certificate for terminating TLS traffic. And you can provision that certificate through AWS Certificate Manager. and it manages all the public key, private key, CSR. It also manages the expiration. So if there is automatically renewal of the certificate is also managed through ACM.
This is not a group, this is just certificates itself.
Correct.
AWS group is assigned.
Yes. Yep. Cloud HSM is a hardware security module. This is, if you're familiar with SafeNet Luna in your environment, so Cloud HSM is a single tenant. Some of the workloads may have requirement of like FIPS 140-2 level 3, or I mean level 3 type of requirement. Like if you are doing digital rights management, or you have like transparent data encryption, Oracle TD, and you want to store the wallet keys. This AWS HSM is available. It's a pay-as-you-go per hour pricing on this one. And you control the access to that. So all the encryption keys are stored inside the HSM, and you control that. We don't have access to it. Again, it's a single tenant. You can use it across multiple availability zones. So you can create 2 of these and do a HA configuration. So there are certain workloads that may need this, but there are others where this is also a FIPS 142-2 compliant service, which is KMS, Key Management Service. Key Management Service allows you to manage the master key, and you get to bring your own key, or you can use a key that we provide. The key never leaves, the master key never leaves the KMS system. The way the envelope encryption works is that you have a key manager that is actually, you have the managed key, master key, and then it creates a data key. And for each data key it is creating, that data key is used for encrypting a specific piece of data. And then encrypted data key and encrypted objects are stored together. You are just interacting with KMS. Every time you want to decrypt it, the KMS would actually decrypt your data key, and then that decrypted data key would be used to decrypt your object. So it's a managed service. It allows you to do rotation. So if you say, I want to rotate my master key every year, you can do that. It also integrates with 19 plus AWS services. So for example, if you want to encrypt a relational database at rest, so you can just point the relational database to a specific key and give it permissions to use that RDS, that KMS key, and it manages all the encryption for you. So a lot of heavy lifting for encryption is taken care for you. Very easy to start using it. The cost is like $1 per month per key, and there is a cost for API requests also. So just shows like encryption at rest. You have the volume encryption, we have the S3 object encryption, and there is a database encryption. It integrates with all the RDS engines that we list there, and then Aurora also, which is not listed there, RDS Aurora. And then you can also encrypt EBS volumes, like for file system. You can also encrypt EFS file systems now. With S3, there are 3 or 4, 3 types of encryption supported. Server-side encryption, where you can have KMS manage the key, you can have S3 manage the key. You can also do client-side encryption, where the objects are encrypted on the client side and then stored in the S3 bucket also. So there are a number of encryption supported here. All of these services are integrated with KMS, so very easy to, there's no good reason not to use KMS. I think you can encrypt everything that is listed here very easily. Just a little, I talked about that, that how KMS works, but when you create a KMS key, there is a master key at the top, and for that master key never leaves the KMS service. We don't have access to it. It's within the service, but the job of that master key is to generate the data keys. These are data keys for every S3 object. So if you encrypt a S3 bucket, every object may get encrypted by a different data key. So when you make a request to store the object, a new data key is generated. This data key is then used to encrypt the object, and then encrypted data key will be stored with the object also. And then the unencrypted data key will be removed from the S3 memory. And when you need the decryption, or when you do a get of that object, that encrypted data key would be then unencrypted using the master key through an API request. And that unencrypted data key will be used to unencrypt the encrypted object. And then that's how the whole hierarchy works here. The rotation of the master key is also allowed if KMS is managing that. So you can say rotate this key automatically. So every year you can rotate the master key. In that, not all previously encrypted object will be unencrypted and encrypted with the new one, but we'll manage the versions of KMS key. So you had the key for the first year, and then the second year, and then it will understand which key to use to encrypt and unencrypt the objects. Also, KMS is integrated with CloudTrail. So CloudTrail is a service that does the audit trail. So any type of changes that are happening in your account. So if you made decrypt results, or there was a specific event that happened, CloudTrail will catch it. It'll also show you who did it, when did it happen, which API was making the call, which user was making the call. So all of that would be available to you. You can also bring your own key, and that is also supported with KMS. So there's other tools in the logging and management space that I want to go over. AWS Amazon Inspector. This is an agent-based service where you can install this agent on EC2 instance, whether it is a Linux, Ubuntu, Windows instance. This is available via GitHub. And what it does is it collects and analyzes all the packages and RPMs that you have, again, evaluates against the CIS benchmark, and then it provides all that information in a central console in an inspector, where you can see how many EC2s are drifting away from the security patches. So you can centralize all of that management of your operating system packages. You can also define certain rules, as in how you get notified. You can also connect it to the Lambda and get notified through that. Another area is the web application firewall. So this is a layer 7 firewall. This is a managed service where you define web access control rules. These rules would allow you to do blacklist and whitelist of a specific IP range that you don't want those IPs to interact with your website. So you can define that. It can also detect SQL injection type of workload at layer 7. So you can define all of those access control layers and then use it with your CloudFront distribution or your load balancer. CloudTrail, we have been talking about that. So anything that happens in AWS, whether it is through console or whether you are writing an API or writing a Python code, all of those API calls are logged. So you can find out who made the call, when was the call made, what was the call, what were the resources that were affected. All of that is available. There are CloudTrail integration out there. So there are a number of partners that have built these integrations that you can ingest these CloudTrail and then get dashboards or even notifications. CloudTrail also integrates with events. So we support certain specific events through CloudWatch events, but CloudWatch API would allow you to define your custom events for a specific API that you're interested in. And that event can actually fire a Lambda function, which is a serverless compute, and you can write your own code in the event of that API gets executed. You can have notification or any actions that you can do any automation with it. On the right, there is an event that just shows a little JSON event that happened. CloudWatch is a service that allows you to do monitoring of AWS resources. So there are a number of things in CloudWatch. We have matrices like CPU utilization, disk utilization, things like that for EC2. There are relational databases. You can also do collect logs. So there's a CloudWatch log service. You can centralize all the logs from your EC2 and analyze it there. You can build dashboards. And then I talked about events, so you can define some events, and you can also do like alarming. So you can say if this particular application is using 80% of the CPU for 5 minutes, notify me. So CloudWatch alarm would allow you to create those kind of alarms also. And VPC flow logs, this is a service that would basically allow you to control, allow you to view what packets are coming in and out of your network, from which ENI or from which elastic network interface, which IP address, which port protocol. So those are also available. VPC flow logs with CloudTrail, you can actually ingest them and put it in like a Kibana dashboard. So we have a service called Elasticsearch, and you can take all these CloudWatch and CloudWatch logs. You can take VPC flow logs. We can take CloudTrail. You can push all of that into Elasticsearch cluster, index them, and build a nice dashboard that can actually provide you a view of what's happening in your environment also. Service Catalog is a service that allows you to build products and portfolios. So if you are thinking about standardizing your environment, like you want to build databases, or if you are building a VPC network or things like that, you can standardize that through the CloudFormation and then put them in the Service Catalog as a product and portfolio, and then share among the AWS accounts. So then they don't have to go through all the heavy lifting of creating CloudFormation. They can reuse that. You can parameterize that. So you can provide like a database name, you can provide database engine, and then it goes and builds the database in a standard fashion. So Service Catalog is a great use case for when you're deploying things at scale. AWS Config is another service that allows you to manage configuration. So things, configuration management in the sense that if there are changes in your infrastructure, you're starting an instance, deleting a network, or creating a database, all of those change events are recorded. Think of it as a sort of like a DVR of your AWS account, where you are collecting all of these events and then passing through, and then you can actually go back in time. So you can say, 2 days ago, what did my environment look like? So you can do all of that. You can also define rules that when certain events happen, fire a Lambda function, and it can actually take an action also. Trusted Advisor is another service. It provides certain checks and balances. So there is a performance, security, fault tolerance, cost optimization. These checks run on behalf of you. So if you have an underutilized EC2 instance, or if you have a security group that is too open to the world, you can find out that also through that. So when it comes to AWS security, it's defense in depth. So there are a number of things that you can do, from the data encryption to the access control to the network, to the basically identity and access management. And so here's a typical architecture, and this will be the final slide. And basically, this is what a typical architecture looks like, where security is first, and they thought about security from the ground up when designing the application. You have the AWS WAF, which is the Web Application Firewall. Route 53 is our DNS service. WAF can actually protect against layer 7 attacks. CloudFront is kind of caching some of that static content, and also using AWS Certificate Manager for ACM, which is the TLS encryption that it provides. And then Application Load Balancer is a managed service to balance your load across multiple availability zones across those two instances. All your EC2s are using the KMS, so you have AMI that is encrypted at rest, and you can also use AMI for encrypting your EBS volumes, which are elastic block storage volumes that you can encrypt them at rest. Your DynamoDB is accessed from your VPC through an endpoint that is saying that the traffic to DynamoDB from your network does not leave and go over the internet. It stays on AWS network. That's the VPC endpoint. And you can control the access through endpoint policy there. All of the actions are being logged in CloudTrail and collected in S3 for long-term storage. And then you have VPC flow log and CloudWatch to look at what traffic is coming in and out of it. So with that, we have number of largest ecosystem of security partners. So some of these tools that you use today on premises, you can use those in AWS also, in addition to what native AWS provides. And these are just some samples. I have some resource slides at the end of the deck that you can use to go and find all the other partners. We also have competency partners, so we have number of partners, and these are not all, again, by each silo you have these partners do a wonderful job, and if you are used to them and you want to utilize their service, by all means use them. They go through a strict certification to be a competency partner here. And you can go to AWS Marketplace, which is like a Amazon.com sort of for retail. There's an AWS Marketplace for the tools and the solutions that you can utilize in your AWS account. So many of these solutions are available through Marketplace also. There is a security center, and I'll leave these slides for you guys to look at it, but there's a security center and compliance center where there's more information. There's a security blog. There are a number of things that are being published there. Some of the resources here, and that's it. Thank you. Yeah, so the question was, when you upload an object in S3, does it do malware check? And is there any service that does it, like Macy or something else, right? And what's the easy way to do it? So no, there is no, right now Macy doesn't support that. So there is no malware checking available. I think the current solution, like is described, would be to pull the object out and then and look at that. Or before you upload the object, run it through the malware solution that you're using today. Yeah, so the question was, there are certifications, and he's interested in security certifications. What's the prior certification that would be better to take if somebody were to do into security, right? Somebody wants to do security. Actually recently, just this week or last week, we are announcing, or we have announced that there is no prerequisite for any of the certification. We are removing that. But my advice, if you are starting out in the security, or if you have a security background, there's a different, people who already have security background can straight away go and take the security certification. Once they get AWS basic security on network security, identity access management, understanding, a little bit of CloudTrail, and all of the blueprint is available on our website. So you can use that to study and do the security certification directly. But if you are completely new to security, even in on-premises, I would recommend doing an associate certification at least. So that would help you with all the other construct around it, like VPC, networking, EC2, security groups, and all of that. And that kind of builds the foundation for security. But there's nothing stopping you from now taking the security directly if you need.